No, I'm not. No, it's not due. It's review.
Okay, because I didn't understand that. I mean, I did, but like, I think it's all wrong.
Okay. All right. We'll start there then. All right. So make sure this is where we're starting today. I'm gonna go through some of this, and then we will kind of go from there. All right. Yes. Where I want to actually make it out of. It is because I didn't get it graded in time to put it in last quarter. I have a note on there that it was given last, but all right. So looking at this sheet again, this was the review sheet that I gave out yesterday. Remember that covalent compounds. So this one is covalent or molecular is what we're dealing with. So remember the names of this one tells us exactly what's there. And then when we're writing the name from the formula, we just copy down exactly what's there. So looking at like this one, antimony tribromide. So the key thing there is that prefix tri. That tells us that there's going to be a 3 somewhere in this. Antimony, we just have to know the symbol, and if that's not one of the ones I assigned, then you just had to kind of look it up. But antimony is SB, and then we have bromine, BR, and it's tri 3. All right. So now, number 7, I neglected to notice this when I printed it out, and I forgot about it. So some covalent compounds, some molecular compounds are going to have common names. One of the ones that we're most familiar with, the common name is water. All right, water H2O. We don't think of it in the sense of naming it as a covalent, because if we named H2O based off of covalent rules, we would call it all right. So water's the official name for H2O is dihydrogen monoxide. We can also call it hydroxy acid or hydroxic acid. All right. So or we can call it hydrogen hydroxide if we look at it as a base. So we can look at water from a lot of different perspectives and give it different names. So that's why we use the common name for it. All right. Now, ammonia is kind of the same way. I think I wrote it on the board yesterday, but ammonia is actually NH3. Now, I do want to distinguish that, ladies. I do want to distinguish that from ammonium. So remember the difference. Remember the difference between these and a polyatomic ion. Notice none of these have charges on them. So, but we could have notice the difference between ammonia and ammonium. All right. Notice the difference between sulfur trioxide and sulfate. All right. So that's things that I want you to do. All right. So looking at number 2 here, we have hexaboron. What's the symbol for boron? B. What does hexa tell us? 6. And then it's monosilicide. So silicide is silicone, and mono is 1, so I'll leave it alone. All right. Number 9, we have dinitrogen trioxide. So dinitrogen, how would I write that? N2, and then oxygen is O3. All right, so any questions on how we're doing those? Yes. I went over them. Yeah, went over a few of them yesterday.
Yeah, but I have a question.
Let me go back to it later. Let me just deal with covalent right now. Yes. Okay.
For number 15, does it always have to be like mono before when it's one?
When it's the second element.
Okay.
When it's the first element, no. So this one, I'm going to call it diboron. And then that's going to be and just do your best with spelling that one. Most of these are going to be like selected response type things whenever you get to them. So, all right. So kind of going through here. So we have P4, so that is tetra. And then it'll be phosphorus. And then S5, so that's going to be pent. Now, I'll say this. When we change the ending of sulfur kind of picks, sulfur doesn't have rules for changing the ending. Sometimes, so like on this one, we drop the UR off and put IDE. But sometimes we'll go back to like, when we're talking about acids in a minute, we'll go back from like sulfate, we'll go to sulfurous or sulfuric. So we'll put the UR back in. So the UR can kind of come and go as it chooses. There's no real rule for it. All right. So the only one that I want to hit on this one that's kind of special is this one. Look at O2. What's different about this compound as to everything else on that sheet? It's just O2. It's just one element. So what we have to recognize this is a molecular element. So for this one, the name is just going to be oxygen. We're not going to call it dioxygen or anything like that. So when you see an element by itself that's doubled, it's just going to be the element's name. All right, so let me see if I can get to that other paper. All right. Yes. Uh-huh. Then, well, O3 is ozone, but I'm not going to ask you that one. But like, so like there is one that's like S6. We'll call that either sulfur or hexasulfur. It does that one. You can kind of go either way. Yeah, yeah. And you'll see. I'm going to talk specifically about diatomics again in a minute. All right. So, if you have a question, Brooklyn, 1 through 10 or 21 through 30.
So on number 8.
All right.
Where does the O go? Because I was confused, so
All right.
Looked it up.
So
and the O just like disappeared.
No, it doesn't. Look at your polyatomic. If you ever see more than 3 elements in a compound, that means, well, let me ask y'all. If I have more than 3, if I have 3 or more elements in a compound, what does that clue us in to do? Where should we look? The polyatomic ion list. So I could break this down two different ways. So on my polyatomic ion list, I'm either looking for Be2S and treating the O as separate, or I'm looking for SO4 and looking for one that does that. And so in this case, we have, no, just sulfate. So it's going to be called beryllium.
So when it has 3 or more elements, you always have to look at the chart to see if it's one of those things.
Yes. So sulfate is SO4 with a -2 charge. And beryllium is,
And then
that actually compound is actually wrong.
it's beryllium with the letter A, the number thing.
No, it should just be BeSO4. All right, that one is actually wrong on the face. Because beryllium always makes a +2. And sulfate is a -2, so it should just cancel out. But I'm not going to pick on that because that's their sheet and all of that, whatever they want.
When do you put the little numeral?
Roman numeral in between. If it is anything that has a column B, if it's anything from these two rows, or if it's transition metal, yes, or if it's these four, tin, antimony, lead, bismuth. All right. All right. So our goals for today. Today we're going to be looking at, I'm going to remind us of the 7 diatomic elements or diatomic molecular elements. Technically they are covalent compounds, but we're going to consider them elements because it's just all of the same thing. We're going to be looking, again, distinguishing between molecular and covalent. The practice that we're doing today is just distinguishing between the two. And then this last outcome, I'm actually going to spend some time with this because I want you to know how to do this, even though our reference pack gives us all the names of the acids that we're going to use. I want you to do this because it is a good, useful skill, and it will save you a little time. All right, so we're going to look at how, if I give you the formula of an acid, you'll be able to write the name of it. So there's 2 different types of acid. We'll look at a binary acid, which includes 2 elements, and an oxy acid, which includes a polyatomic ion. All right, so starting off, diatomic elements, also called molecular elements. There are 7 of them. So some elements in nature, they're highly, highly reactive. They don't like to be alone. So if given the opportunity, they will bond with themselves. Those 7 elements, we can kind of use the acronym Brinkelhoff to remember them because it includes the names of all the elements. All right. But again, these elements that like to bond to themselves, we call them diatomic molecules or molecular elements, diatomic elements, a lot of different ways to mix them. But if you look at the little acronym Brinkelhoff, every capital letter represents an independent element. So we're looking at the 7 elements that are diatomic. When they're by themselves in nature, they will always be written as a diatone. All right. So Br, bromine, is Br2. Iodine is always I2. Nitrogen is always N2. Chlorine is always Cl2. Hydrogen is H2. Oxygen is O2. And fluorine is F2. the kind of key thing here is all right. This diatomic nature of it doesn't carry over to when it's in a compound. So hydrogen in a compound doesn't have to have a 2 next to it. But hydrogen, when it's by itself, has to have the 2 next to it. All right, questions on that? So we can have a compound between hydrogen and chlorine that's HCl, but we can also have a compound that's H2O, but when hydrogen's by itself, it's always going to be written as H2. All right, so we talked about that earlier in the semester. I just want to refresh that because there will be questions asking about that. One of the active questions asks a question like, which of these is a diatomic element or something like that, a molecular element? And so you have to look for the one that's one of those. Another one asks, which of these is a diatomic molecule? Well, a diatomic molecule, or not a diatomic molecule, but which one of these is a molecular compound? We're looking for a covalent compound. If it asks which is an ionic compound, we're looking for a metal and a non-metal together. All right. So, kind of the thing, this is a skill that I'm teaching. They're not going to ask you to do this on a test, but I want you to recognize why it does what it does, why it looks like what it looks like. I would. Like I said, this is a skill that can help you do things faster if you have it, rather than having to look it up or figure out where it is and things like that. So when it comes to naming acids, we have to look at the different types of acids. So when I look at the formulas for acids, I have things like HCl, H2S, HF, HBr. But I also have acids that look a little bit different formulaically. I can have something like HC. I always forget this one. I'm going to leave that to you. All right. So what do you notice? What's the common factor for the ones on the left? Two elements. So these are all binary. What's the common factor, or what's a common factor that we see in every one of those compounds on the right side? Okay, there's more than 2 elements. There's something else that I want us to kind of notice. They're polyatomic ions, and they're polyatomic ions that all contain oxygen. So these can be called tertiary acids or ternary acids, but the name that I'm going to use today is oxy acids. All right, so these are all oxy acids because they contain oxygen. All right. So now, of both sets of lists, what's the one thing that you see in common in both lists? hydrogen, and specifically, where is the hydrogen located? At the front of the formula. All right, so identifying an acid always contains hydrogen as its first element. Another class of compounds, which is technically that we consider the opposite of an acid, is a base. And a base is simply an ionic compound that contains a hydroxide ion in it. All right. So an acid will always have hydrogen as the first element. And a base will usually contain a hydroxide ion. No, because three main classes of compounds well, there's more than three, but three ones that you're going to hear me talk to by name. I'm going to call something either a salt. That's an ionic compound that just contains a metal and a nonmetal. I'll say a base. That's a compound that contains some metal and a hydroxide, an OH. Or I'll say an acid. That's a covalent compound that has hydrogen as the first element. All right. The other things then is just regular covalence. There's organics. There's things like that. But I'm not going to get necessarily into those categories as far as knowing the name. All right. So there are some rules for naming these. But let's just see how we do with identifying each. You don't have to worry about writing this next one down. We're just going to kind of do it as a whole class practice. All right. So if it is an acid, we're going to mark A next to it. If it's a base, we're going to say B next to it. So looking at that first one, BaOH2, based on the two definitions I just gave you, is that an acid or a base? Base. All right. And the thing that makes it a base is the OH. All right, what about H3P? Acid, because that's in the front. All right, what about NaOH? All right, what about, I'm sorry. All right, what about H3PO4? Acid. All right, and then acid. Now, I'm going to write, so we talked about water earlier. If I write it as H2O, what would you think of it as? An acid. I can also write water as HOH, and it becomes a base. All right. So acid, water is a class of compound that's considered to be amphoteric. Amphoteric means it's an acid or a base. All right. It just depends on the situation, and it can act as either one. So you'll find a lot of chemistry is based off of water doing multiple things. Mainly probably because it's one of the most common substances we have. All right. So when it comes to naming a base, all you really need to know is if it's a base, you name it just like any other ionic compound that's in there. So, if I have BaOH2 based off of ionic naming, I come through, I name the metal. Barium, and then the OH is hydroxide. Nothing changes from anything that we've taught so far. So naming a base is just strictly ionic rules because a base is an ionic compound by nature. It's going to be a cation and the anion OH. Now, Naming an acid. Southeastern professors are really, really nice. We used to have to know how to do this, but since last year, they started including this list in your reference packet. So if you turn to the last page of your reference packet, or the second to last page, you should have this box somewhere in there. And it gives us pretty much every acid that we'll use in this class, and it's already named for you. All right, so just kind of know that that's there. So most of the acids that we use in this class are included in our reference packet, but I want you to know the skills of being able to do it, just in case you're in a bind. All right, just in case on a test they throw up an acid that we've never seen before that's not on this list, because this is not every acid that exists. This is just some of them. All right, so as I said before, there's two different classes of acids. It's either binary. If it's a binary acid, what should the formula have in it? If it's a binary acid, what does binary tell us? What does bi tell us? 2. All right. So binary acid is going to contain two different elements. What is one of those elements always going to be? Hydrogen. All right. So in a binary acid, we're going to look at the anion. In the formula, where is the anion located? The first element or the second element in a binary? The first. Anion. What charge is an anion? It's negative charge. Anion is always the second element. Cation is always positive. It's always the first element. So when we're looking at a binary acid, we're going to change the anion ending from IDE to IC. And then we will add the prefix hydro to the front, which hydro is going to represent the hydrogen. And then we will add the word acid. So let's look at an example. Which of these two elements, H or Cl, which one is the anion? Cl. What is, if I was naming this based off of ionic rules, what would that Cl be called? Chloride. Chloride. All right, that's what it would have been off. Listen to the question that I'm asking. Based off of ionic rules, what would that Cl be called? Chloride, because it's at the end, right? It's the second element. All right. So chloride becomes chloric. The IDE becomes IC. Now, if I want to put this together in the format for naming a binary acid, it becomes hydrochloric acid. Does that make sense? All right, so let's look at one more example. All right. So an alternate example would be HF. What would that F be called originally? Fluoride. So fluoride is going to become fluoric, and then making it, finishing it off, I'm going to say so the only time you're going to use that format is if it's two elements and hydrogen is the first element. All right. Now, oxyacids are acids containing polyatomic ions, and it's polyatomic ions specifically that contain oxygen. All right. So an oxyacid is an acid that contains polyatomic ions. So what I want you to know is I use this little statement to help me remember some things. I didn't say polyatomic acid ever. I said polyatomic ion. We have a whole list of them in our periodic table reference packet on page 3. And it's ions that contain 2 elements in it that makes it with a charge. So like nitrate, carbonate, those things. Polyatomic. Poly. What does poly mean? Multiple. Atomic. What is atom? So we have poly means more than one. Atomic means atom. So more than one atom. And then ion means charged. More than one charged atom. All right. So 4 oxyacids. I remember this statement. Ick, I ate a humongous bite. Notice that I have IC and ATE in red, and I have OUS and ITE in purple, so I can distinguish those two. Where have you seen ATE and ITE before? Polyatomic ion names, right? So what do you think is going to happen to a polyatomic ion that ends in ATE? It's going to become IC. If it ends in ITE, it's going to become OUS. So an ATE ending changes to IC, and an ITE ending changes to OUS. So if we have, so I'll give this example. And I'm not putting it in an acid just yet, but what polyatomic ion, if I look at the polyatomic ion list, and I find NO3 negative, what polyatomic ion is that? All right, so that's nitrate. If I had nitrate included in an acid, what would the new name of this polyatomic ion become? All right, and using the same format, if I used NO2 negative 1, that is nitrite, and that becomes nitrous. All right. So does everybody kind of follow what's happening there? Now, unlike binary acids, when it comes to naming an acid that has a polyatomic ion in it, or naming an oxyacid, we don't worry about talking about the hydrogen at all. The hydrogen's there, but we're not going to name it in the name. So oxyacids, when we have an anion, the second grouping of elements ending in ATE, we change the ATE to IC. We already covered that. And then we follow that with the word acid. So let's look at an example, and I'm going to give you the one that I used on the previous slide is NO3. So looking at this acid, HNO3, which part of it is the anion? NO3. What was the name of that anion? Nitrate. So NO3 negative nitrate, NO3 negative nitrate changes to nitric. And then to complete the name, what are we going to call this? Nitric acid. Does it make sense? All right, so let's look at another example. In this compound, which one is the anion? SO4. What is the name of SO4? All right, sulfate. So what is going to be the name of this acid based off of what we should do? All right, so sulfur, again, is the tricky one. That's the one where the UR can come back and go away as it chooses. So by rule, it should be sulfic acid, but that doesn't sound right to your ear. It's sulfuric acid. So just know that phosphorus kind of does the same thing because phosphic acid doesn't sound as good as phosphoric acid. And so we have to sometimes we have to kind of play with the letters that we've dropped out of the original name to make it sound better. But for the most part, that's where you're going to look at. Yes. So you're never going to be asked to spell it. So you're going to be given, most of the time, these will be given within a multiple choice that you're having to do. So you're not ever going to have to write it out. You'll be given specific choices to drop and drag and things like that. All right. So the other side of oxyacid, an anion ending in ITE. So as I said before, the ITE changes to OUS. And then we're going to follow it with the word acid. So looking at this one, H2SO3, which part of this formula is the anion? SO3. What is the name of SO3 based off of your list? Sulfite. All right. So the SO3 negative 2 anion is going to change from sulfite to sulfurous. All right. And again, sulfur is that funny one that it has to drop and pick up letters, and it just because it sounds better, I think. All right. So what would the name of H2SO3 be? Sulfurous acid. All right. Let me see another one that I can do real quick. All right. All right. So to pull a different polyatomic ion than what I've been using. So looking at this one, HClO2. What grouping is our anion in it? ClO2, right? Look it up. What is the name of ClO2 negative 1? So what will the name of this acid be? No hydrogen. Yeah. Chlorous acid. So notice binary acids, we talk about hydro whatever ick. All right. So I'm going to show you. All right. So let's go back to, let's look at a binary. So we had H2SO4 earlier, right? And we named this that sulfuric acid. All right. Then we had H2SO3 and we named it sulfurous acid. All right. In every acid, there's always an H. But what if I had a binary acid that contained a hydrogen and a sulfur? What is the name of that one? So the sulfide becomes sulfuric, but because it's binary, I have to say all right. So if we see hydro in front of it, we know it's binary. If we don't see hydro in front of it, we know the hydrogen's there, but we can't, if we put hydro here, there's no way for me to distinguish this acid from this acid. So this one contains an oxyacid, so we drop the naming of hydrogen off. This one is binary, so we still include the hydrogen. So in polyatomic ions, we just have to understand that the hydrogen is there. We're just not going to name it in the name. And the reason why is because there could be confusion. You know, if HCl, hydrochloric acid, I have a version that is chloric acid. And so I want to make sure I can distinguish between the two. All right. So go ahead, see if you can get the formulas from these three names. Treat these as ionic. You may have to use crisscross whenever you're setting them up. So remember, think about what charge hydrogen makes and what sulfate is a -2. Same thing we've been doing to write the formula. Crisscross method. I got to change the charge, set up a ratio. So it's going to take 2 hydrogens to react with 1 sulfate. All right. Sulfuric is sulfate. We just talked about that. If it's IC, that means it's ATE. So I look up that. So OUS should be OUS and ITE are connected. So what's the formula for phosphite? So I have an H plus and PO3 -3. All right. Sulfuric. All right. So this one, we have hydro in front. So that means that this has to be binary. So I'm not looking for a polyatomic ion there. So that means that's sulfur. Sulfur's a -2. Hydrogen's a +1. H2S. All right. Of the two skills, going from the name to the formula is more important than going from the formula to the name. All right. Because on a test, the one that's really going to mess with you is you're going to need the formula, and you're going to need the formula in the correct ratio when we start putting math with these things, or you're going to come out with bad numbers. Trace, yes. Yeah. Yeah. All right. So now let's go back to our list that we had before, and let's see if we can name them along with identifying it as an acid or a base. So we identified BaOH before as a base, right? What should the name of this be? So remember, base is just following ionic rules. So what is Ba? Barium. What is OH? Hydroxide. So it should be barium hydroxide. That one's not an acid, it's a base. All right. We identified H3P as an acid before. So it's a binary acid. So what should it start with? Hydro. And P is phosphorus or phosphide. So it's going to be phosphoric. So hydrophosphoric acid. All right, NaOH, acid or base? That is a base. So what is the name of this one going to be? Sodium hydroxide. All right, H3PO4 is an acid. So we're going to look at what PO4 is on the polyatomic ion list. It is phosphate. So phosphate becomes ic. So it's going to be phosphoric acid. So again, a couple of the elements, phosphorus and sulfur, they add letters back to make it sound better. All right, and then HNO2. NO2 -1 is nitrite. Nitrite becomes nitrous. So that becomes nitrous acid. All right, it's not, so the acid-base stuff is not difficult. And again, if you don't want to memorize, if you don't want to know how to do it, you can let it go out of your head, because you do have the list right there next to your polyatomic ion list. All right, most of the acids that we will use in this class are included right there. So you might run into one or two, maybe on an active question or something like that, or on a worksheet that I give you that's not listed on there. But from that, it's not going to be a major thing. All right.